Hi. Now in this question we're given this diagram here that shows two particles P and Q of masses 0.2 and 0.3 kilograms respectively, which move on a horizontal surface in the same direction along a straight line. Then we've got a stationary point R of mass 1.5 kilograms also lies on this line. P and Q collide and coalesce to form a combined particle C. Then immediately before this collision, P has velocity of 4 meters per second and Q has a velocity of 2.5 meters per second. And what we've got to do is to calculate the velocity of C immediately after this collision. So if you'd like to have a go at this, if you haven't done so already, just give you a moment to pause the video. Do come back when ready and you can check your work solution against mine. Okay, welcome back then if you had a go. Well, the first thing I'd want to do is label this diagram as a before impact, okay? And then we're going to look at what happens after impact. And so these two particles P and Q join together to make another particle, okay, which has a combined mass of P and Q. That would be 0.2 kilograms and 0.3 kilograms. So it's going to be 0.5 kilograms. And this particle then is called C. And then afterwards, we've got to find the velocity of C immediately after this collision. So if we just say it's going to move to the right with a velocity, let's say Vc. Now to find the velocity Vc, what we need to use is the conservation of linear momentum. Just write it for short like this, okay? Now I'm assuming that you're familiar with the conservation of linear momentum. What it is essentially that the momentum before impact equals the momentum after impact. And we're dealing with vector quantities here, so we need to set up a positive sense. So I'm going to take to the right as positive. It doesn't matter which way you take as long as you stick to it throughout the problem. But I'm taking right as positive because I can see that Vc will be in the positive sense. Now, the momentum, remember, is mass times velocity. So if we take first of all the momentum of particle P, its mass was 0.2 kilograms, so we've got 0.2 then multiplied by its velocity, which will be 4 meters per second. It's in the positive sense, so it's going to be plus 4. Okay. Now to this we add the momentum of Q, so it's its mass, which is 0.3. And we multiply this by its velocity, which is 2.5. Again, it's in the positive sense, so that will be multiplied by 2.5. And this now equals the total momentum after impact. Well, the mass is the mass of C, which is 0.5, and the velocity is Vc, and it's in the positive sense, so we can just write that as Vc there. So working out the left-hand side comes to 1.55. So therefore we get 1.55 equals 0.5 Vc. And to get Vc, we just need to divide both sides by 0.5. And if you do that, you find that therefore Vc equals 3.1 meters per second. Okay?